Assalamu alaikum students. I welcome you to the online course on Principles of Communication Systems. I am Ayaz Ahmed, Assistant Professor in the Department of Electrical and Computer Engineering, ComSat, University Wa Campus. Okay. So in today's lecture, I will provide you some basic information related to this course, and then I will introduce communication system and the different components of a communication system. Okay. So we start with the course information. The prerequisite for this course is signals and systems. Okay. So in order to have good understanding of this course, you need to have a basic understanding of signals and systems. Okay. This is a 4 credit hour course. Okay, where 3 credit hours per week for the theory part and 1 laboratory session per week for the laboratory part, where each laboratory session is of 3 hours duration. The textbook for this course is Analog and Digital Communication by B.P. Lati. Okay, here I have mentioned 4th edition. But you can use any edition of this book. Okay, so here we have a couple of books as reference book. So the first one is Communication System by Simon Haken. This book contains both analog and digital communication. Similarly, then we have Digital Communication by J.J. Prokis. In this book you can find only digital communication part of this course. Similarly, we have Analog and Digital Communication System, and another book which is Digital Communication System Fundamentals and Application by Bernard Sklar. So in this book also you can only find the digital part of this course. Okay. So here we will see the main objectives of this course. In this course we will cover the basic principles and techniques used in analog and digital communications. Then we will study baseband and band pass communication techniques. Okay, so the terms baseband and band pass will be clear later in this course. Okay, so don't worry about these terms at this moment. Okay. Then we will study analog modulation and demodulation techniques. In analog modulation, we will study amplitude modulation, frequency modulation, and phase modulation. Okay. Finally, we will cover the fundamental and important concepts of digital communication systems. So in this part, we will study the basics of digital modulation and demodulation techniques. Similarly, analog to digital converter and digital multiplexing techniques. Okay. Here are the course learning outcomes of this course. Okay, so we have 4 course learning outcomes which we call CLOs. Okay, so the first course learning outcome is that after completing this course you will be able to comprehend the basic concepts of communication, and similarly you will understand signal representation, signal transformation, and the application of these concepts to the analysis of communication systems. Okay. Course learning outcome number 2 is to demonstrate the principles of analog modulation and demodulation, and then the analysis and evaluation of their performance. Okay. Course learning outcome number 3 is to describe the fundamental concepts of digital communication systems. Okay. And course learning outcome number 4 is related to lab. Okay, so this learning outcome is related to the implementation of the learned concepts on communication lab equipment and on modern IT tools. Means that after successfully completing this course you will be able to implement the learned concept on communication lab equipments as well as in MATLAB. Okay. So here we have the tentative assessment plan. Okay, so as you all know that we have quizzes, assignments, 2 sessionals, sessional 1 and sessional 2, and then we have terminal exam. Okay, so 15% marks are assigned to quizzes, then the weightage of assignment is 10%. The combined weightage of 2 sessional exams is 25%, where 10% marks are given to sessional 1 and 15% marks are given to sessional 2, while the weightage of the terminal exam is 50%. Okay. Similarly, in the laboratory, we have assignments and projects, okay, with 25% weightage. Then there are 2 lab sessional exams, lab sessional 1 and lab sessional 2, okay. Both combinedly have 25 marks, where sessional 1, lab sessional 1 has 10 marks and lab sessional 2 has 15 marks, okay. Then 25% marks are assigned to lab performance and 25% marks are given to the final lab exam, okay. So here is the week-wise schedule and topics which will be covered in this course, okay. So here we have week number, so, and here we have the topics, okay. And week number 1 we will have introduction to communication systems and the different components in the communication systems like transmitter, receiver, channel and so on, okay. And week 2 and 3 signals will be introduced, like we will study what is periodic signal, what is non-periodic signal, what is the difference between analog and digital signals. Similarly, we will study energy signal, power signal and so on, okay. Then week number 4 and 5 the analysis and transformation of signals will be covered, okay. So like the analysis of signals and then transformation like Fourier transform, etc. will be covered in week number 4 and 5. Then in week number 6 we will have first sessional exam, okay. And week 7 and 8 we will consider amplitude modulation, okay. So in amplitude modulation we will study double sideband suppressed carrier amplitude modulation, amplitude modulation with carrier, single sideband modulation, vestigial sideband modulation and so on. And similarly we will study different amplitude modulation and demodulation circuits, okay. Then in week number 9 and 10 we will study frequency modulation and phase modulation, okay. In frequency modulation we will study narrow band frequency modulation and wide band frequency modulation. Similarly we will also study the circuitry used for the generation of frequency modulated signal, okay. And week number 11 we will cover sampling and quantization, okay. So from here the digital part of this course will start, okay. Then in week number 12 we will have second sessional exam, okay. And week 13 and 14 we will cover the basics of digital modulation and demodulation, so like amplitude shift keying, frequency shift keying, phase shift keying and so on, okay. And week number 15 we will study the basic principles of digital data transmission like line coding, pulse shaping and so on, okay. And week 16 we will study multiplexing techniques like time division multiple axis, frequency division multiple axis and code division multiple axis, okay. So now here we see what is communication, okay. So looking here, if we have 2 persons and they are conveying thoughts, feelings, ideas and facts, so this is called as communication, okay. Or in other words, communication is the exchange of information, okay. Then we have electronics communication, okay. So in electronics communication the data is sent and received, or the information is sent and received by using electronic means. So looking here, this is an AM FM radio set, okay, and this is the N side of this set, and you can see here that we have a number of electronics components. So here we have capacitor, here we have an inductor, similarly here we have a transistor, this is a speaker, okay, and similarly here this is a transformer, okay. So looking here, this is the antenna, so, okay. So now this radio set is made of electronics devices or electronics components, okay. So now here we have few examples of electronics communication systems. Okay, so looking here, this is an analog TV in which the signal is transmitted from the TV signal is transmitted from this antenna, which is received via these small antennas on the TV set. Okay, so here we have a digital TV. Okay, and digital TV system, the video is transmitted in the form of digital messages. Okay, here we have another example. Okay, so this is landline telephony system and this is cell phone system. Okay, so these two communication systems are also electronics communication systems. And finally we have another example. We have an analog radio, and here we have a digital radio set. Okay, so this is another example of electronics communication systems. So now we will consider a basic communication system by using this block diagram. So here we have a source, then we have input transducer, a transmitter, channel, a receiver, and an output transducer. Okay, so now we will study each of these blocks in detail. Okay, so this source basically is the entity which originates the message. So it may be, for example, a human, okay, who speaks, or it may be a computer which provides digital data in the form of zeros and one, or some other devices. Okay, so the input message which is generated by the source or originated by the source may be, for example, human voice, a television picture, or data. Okay, so now this input transducer is used to convert the input message signal to an input signal, where input signal is now transmittable over this communication system. Okay, so for example, if the input message signal is generated by a human, which is the speech signal, then this speech signal cannot directly be transmitted over this communication system. Okay, so it first needs to be converted to an electrical waveform. Okay, and this input transducer converts this speech signal to an appropriate electrical waveform, and that electrical waveform is called as the input signal. Okay, and now that electrical waveform can be transmitted over this system. Okay, similarly, if the source is a computer, then this input message will be made of zeros and ones. Okay, and zeros and ones are not transmittable directly. Okay, so in that case, this input transducer will convert the zeros and ones to appropriate electrical waveforms. Okay, and these electrical waveforms are called then input signals. Okay, and these input signals are then transmitted over the communication system. Okay, these input signals here are also called as baseband signals or message signals. Okay, so here we have input message, this is input signal, this signal is also called as baseband signal. Okay, then we have transmitter. This transmitter takes the output of the input transducer and transmit it to the receiver through this channel. Okay, so basically this transmitter will modify this input or baseband signal to another signal in order to efficiently transmit it. Okay, so this may involve modulation, similarly sampling, quantization, coding, and so on. Okay, then we have channel here. So the channel basically is the medium through which the transmitter output here, this transmitter output, is sent to the receiver. Okay, this channel may be a wire. Okay, so for example, if we have a telephone system, okay, so landline telephone system, and landline telephone system, a cable is running from the local exchange to your house. Okay, and when you pick up your telephone receiver, okay, and you try to call to someone, then this signal is transmitted through this wire from your house to the local exchange and then onwards to the desired destination. Okay, similarly, if we have a TV system, so for example, if we have a cable TV system, then in cable TV system the channel basically is a coaxial cable. Okay, so the coaxial cable comes from the TV transmission station to your house. Okay, and then the video is transmitted through that coaxial cable to your house. Okay. Similarly, optical fiber is also used, okay, as a channel. For example, the internet provided to our campus, WA campus, is through optical fiber. Okay. Similarly, we have radio link. Okay. So, for example, in case of AM, FM radio transmissions, the channel used is a radio channel in which the signal is directly transmitted through the air to the transmitter. So, in case of modern communication, the channels are generally divided into two categories: wireline channels and wireless channel. So, for example, wire, coaxial cable and optical fiber comes under the category of wireline channels. Okay, while radio link comes under the category of wireless channel. Okay. So here we have a block which shows the distortion and noise. So generally, when we transmit signal, okay, and the signal travels through the channel, then the channel may distort the signal, or similarly it may add noise to the signal. Okay, so now we have this receiver here. Okay, this receiver takes the signal from the channel, okay, and it removes the distortion and the noise added to the signal when it passes through the channel. Okay. The receiver generally consists of a number of components. Okay, for example, demodulator, decoders, filters, etc. Okay. Then we have this output transducer. Okay, so here the output signal of the receiver is an electrical form. Okay, so now this electrical waveform is needed to be converted to the desired output message signal. Okay, so this output transducer converts this electrical waveform or electrical signal back to the original message signal which was generated by the source. Okay, so for example, if we have a telephone communication system, then this electrical waveform will be converted to a speech signal. Okay. Similarly, if we have a digital communication system in which data is transmitted from computers or mobiles, then this output signal, which is in the form of electrical waveforms, should be converted to zeros and ones. Okay, so this output message signal in that case will consist of zeros and ones, and this operation is performed by the output transducer. Okay, so this was the general introduction of a communication system. Okay, so now we will study the difference between analog and digital messages. Okay, so for example, as shown here, so analog message when converted to electrical waveforms will be represented in the form of a smooth and continuous waveform as shown here. Okay, so you can see here that this is an analog waveform. Okay, so now this waveform is made of infinite points as shown here. Okay, then we have digital message. So in case of digital message, the message is made of a finite number of symbols. For example, if you have a text message, okay, so inside the text message you will have any of the 50 symbols. For example, you will have a combination of letters, English letters, which are 26 total in number. Similarly, we have 10 numbers, so you will have a combination of these 10 numbers. Then you can have a space, and there are several punctuation marks. So any text file, okay, or text message will be made of a combination of the 50 symbols. Okay, so that's why we say that digital message is made of finite number of symbols. Okay. Similarly, if we consider binary message, so in binary message we will have two symbols, 1 and 0. Okay, so any binary message is made of combination of zeros and ones. Okay, Digital signals are transmitted by using a finite set of electrical waveforms. So if we have, for example, a binary communication, so we have a 1 and 0. So one waveform is used for transmitting a 1 and another waveform is used for transmitting a 0. For example, looking here, if we have a 1, then we transmit this waveform which has a magnitude of a over 2. Okay, then if we have a 0, okay, for 0 another waveform is transmitted which has a magnitude minus a over 2. Okay, and so on. So now we will see the immunity of digital signals. Okay, so generally digital signals are said to be immune to noise, means that digital signal can efficiently deal with noise and distortion. Okay, so looking here, we have a digital signal. So in this digital signal we have two labels, a over 2, a positive label which represents a 1, and then we have a negative label which represents a 0. Okay, so now it means that any positive label will represent a 1, a binary 1, and any negative label will represent a binary 0. So if this signal is transmitted through the communication system, then it will be distorted as well as noise will be added to it. Okay, so now at the receiver, if the receiver receives a positive label, then the receiver will decide that the transmitted signal was a 1. Similarly, if the receiver receives a negative label, then it will decide that the transmitted signal was a 0. Okay, so now looking here, this is the distorted version of this original digital signal. Okay, in this distorted version we don't have noise. Okay, here this signal represents this distorted version with noise added to it. Now if this distorted signal is received by the receiver, then the receiver can easily recover this original signal from this distorted one. Okay, so now look here, as the receiver needs to see only the label. So looking here, this is a positive label. Okay, so now reading this positive label, the receiver will decide that the transmitted signal was a binary 1. Okay, similarly looking here in this region, we have a negative label. Okay, so when the receiver receives this negative label, it will decide that the transmitted signal was a binary 0, and so on. Okay, and that's why it is said that digital signal can be easily recovered even when they are distorted and when noise is added to them. Okay. Okay, this completes our today's lecture. Thank you.